Hello, yes, and welcome to our Objective 8 notes, and this is going to be just part 1 of our Objective 8 notes. Now, Objective 8 is I can determine whether a relation is a function. Today, for part 1, we're actually not going to get too much into the definition of a function or anything like that. We're going to really focus on relations and different ways that we can write relations and represent relations. So we're going to talk about XY tables, coordinate graphs, mapping diagrams, equations, and coordinate pairs. We're going to do all of that today. That way, tomorrow, we can really analyze what is and is not a function. So the first thing we're going to look at are XY tables. Now, XY tables can be horizontal or vertical. The X values, or input, will go on top or on the left of the table. And notice that they are in least to greatest, or from left to right, or least to greatest, top to bottom. All right, the Y values, or the outputs, will go on the bottom or right of the table. And those are labeled. Notice these labels. We have X, and this tells me all the X, Y, there's all my Y values, my inputs below, my outputs like so. So those are XY tables. Next, we'll look at mapping diagrams. All right, mapping diagrams are similar in that they list our inputs and our outputs. All right, and then the line or arrow connects the input with the output they produce. So these lines and arrows are really specific. All right, the 0 specifically goes to 3 because the 0, the input, presents the output of 3. All right, the value go down in set from least to greatest, like earlier with the XY tables. All right, so both of them now will go from least to greatest. So I'll always have my least at the top, my greatest at the bottom. The inputs are on the left, while the outputs, or Y values, are on the right. And there does not necessarily have to be the same number of inputs as outputs. For example, look at this one here. This one has 3 inputs but only 2 outputs because -1 and 0 both produce the same output of 1. So now that we have XY tables and mapping diagrams down, let's do some rewriting here. Rewrite the following XY table as a mapping diagram. So to do that, I need to see my inputs, -x, -3, 0, 3, 6. So I'll start by just making a list, -6, -3, 0, 3, 6. And that is my inputs. So I'll make those in a box and label those as inputs. Now my outputs, go ahead and make a box here. Notice my outputs, 4, 2, 4, 8, 16. So I really only have 4 distinct outputs because 4 repeats itself twice. So I only have 2, 4, 8, and 16. So for my list here, I'd say 2, 4, 8, 16. Those are my outputs. Now I need to draw my arrows connecting. So -6 produces 4, so that'll go right there. -3 produces 2, those will go like that. 0 produces 4, so it'll just go like this. 3 produces 8, right across. And 6 produces 16. There we go. And this is our mapping diagram for this XY table that we were given. All right, what I would like you to do, go ahead and rewrite the following mapping diagram as an XY table. So what we did earlier with number 1, I would like you to flip that process, create an XY table out of this mapping diagram. Go ahead and pause the video, give that a shot, and then we'll check it together. All right, let's check how we did. So I'm going to start by just creating a list of x's, and I like to do this first before I try to make my table. So I have -4, -2, 0, and 6. And then from that, I'll make my table. -4, -2, 0, 6. Beautiful. I can do that across. My Y values, -4 produces 14. -2 produces 7. 0 produces 21, and 6 produces 0. There we go. So hopefully our XY tables match. Make sure that we have this same order here. -4 goes to 14, -2 to 7, 0 to 21, and 6 to 0. Fantastic. So those are XY tables and mapping diagrams. Now let's look at coordinate pairs. We're probably familiar with these. They're in the form x comma y, or of course input are x and output y. The coordinates are separated by commas and surrounded by brackets. So each coordinate pair you see is separated by these commas right in here. And then we have these brackets on the outside. Yeah, awesome. So we are going to rewrite the following set of coordinate pairs as an XY table and as a mapping diagram. Alright, so let's start with the XY table. So I'll label my X. I have -3, -1, 0, 2, and 5. And notice again those go from least to greatest. Going to leave myself enough space for my y's to go below there. So there's x. Now the y's we produce are -3 produces 6, -1 produces -4, 0 produces 6, 2 produces 5, and 5 produces -3. All right. Now for my mapping diagram, let's list my inputs here. So I had -3, -1, 0, 2, and 5. I'll put those all in a box. And then my outputs, remember this is from least to greatest, not necessarily the order that they go in. So I need -4, -3, 5, and 6. We can make a box with those. Fantastic. All right, now connecting. -3 produces 6. -1 produces -4. 0 produces 6. 2 produces 5. And 5 produces -3. Fantastic. So those are what those coordinate pairs might look like as an XY table and as inputs and outputs. Next, let's go to coordinate planes. All right. Looking at coordinate planes, so recall all the components of the coordinate plane we've already talked about. The x-axis, remember this horizontal is the x-axis. Our y-axis is the vertical up top here. Our y-axis. Our origin is that point where the axes cross, 0, 0 right there. Our quadrants, remember we start in the top right. This is quadrant 1, quadrant 2, quadrant 3, and quadrant 4. Now we also might see some data like this where it just specifically zooms in on one of the quadrants. So for example, this is specifically zooming in on the first quadrant here, but we can still see our x-axis and our y-axis. Excellent. So with that being said, we're going to write the data represented on the coordinate plane as coordinate pairs in the XY table and as a mapping diagram. Okay, so that's a lot that we're going to do with this one. Let's start with coordinate pairs. So notice how many data points we have. We have 1, 2, 3, 4, 5 data points. So let's start with a bracket here. My coordinate pairs, I'm going to go from left to right. So I have -4, 2, and each of these are separated with a comma. I have -2, 1. I have 1, -3. I have 3, 4, and I have 5, -1. So there it is listed as a coordinate pair with those brackets surrounding the outside. All right, so now let's do the XY table. So my x's are -4, -2, 1, 3, 5. Go ahead and fill in this table here with that information. -2, 1, 3, 5. Excellent. My y values, -4 goes to 2, -2 is 1, 1 is -3, 3 is 4, and 5 is -1. Excellent. All right, now for my mapping diagram, I'm going to list my x values. So I have -4, 2, 1, 3, 5. Put all those in a box. Remember, these go from least to greatest in descending order. So those are my inputs. My outputs are, let's see, the least one is -3, and then -1, and then 1, and 2, and 4. I put those in a box. Label those as my outputs. Fantastic. All right. -4 produces 2. Oh, that was not a straight line. Let's try that again. -4 produces 2. -2. Oh, this needs to be negative. There we go. -2 produces 1. 1 produces -3. 3 produces 4. And 5 produces -1. Fantastic. So we have taken this coordinate plane, we wrote it as coordinate pairs, an XY table, and as inputs and outputs. Now the last thing we're going to do today is work with equations. All right, so we're going to use this equation provided to create at least 4 data points. Plot or chart the data points in all the methods stated. So all the methods we've looked at today, we're going to use that to graph this equation, y equals -x plus 3. So the first thing we need to do here is, looking at these equations, we have to create values. All right, so what I would do is I would make an xy table to start. So let's go ahead. We can make this table like so, x, y, and it says a minimum of 4, but let's do 5 or so. Okay. So -x plus 3. I'm going to use the x values of -2, -1, 0, 1, and 2. And those really can be any x values. I'm looking at the graph I'm going to chart here, so I'm going to make sure that they're close to the center, right? So I can plot these points. I want to be able to do that for sure. All right, now to figure out what my y values are, I need to plug in my x values into this equation. So to do that, I'm going to use some space up top here. So starting with -2, y equals -2, the opposite of -2 plus 3. So that would be 2 plus 3, which is 5. So when x is -2, y is 5. Now when x is -1, I would have the opposite of -1 plus 3. Well, that would be +1 plus 3, which would give me 4. When x is 0, I would just have 0 plus 3, so that's 3. When x is 1, I would have the opposite of 1 plus 3, so that'd be -1 plus 3, which is indeed 2. And you can probably see the pattern that's coming here. 5, 4, 3, 2. Guess what this one's going to be? 1. Yeah. All right. If you see that pattern, use it. All right. When we're working with equations, especially linear ones, we're going to look for that pattern. That pattern, or the slope, tells us the change between each x and y intercept. All right. So that's important. So now that I have this xy table, let's make a mapping diagram. So I'm going to say my inputs are -2, -1, 0, 1, 2. And my outputs, remember this needs to be from least to greatest, so it'd actually be 1, 2, 3, 4, 5. There we go. Now -2 goes to 5. -1 goes to 4, 0 goes to 3, 1 goes to 2, and 2 goes to 1. There we go. All right, so what coordinate pairs are we working with? Well, let's make that outside bracket. So my first one's -2, 5. Then I have -1, 4. Then 0, 3. Then 1, 2. And I have 2, 1 as well. Close that. If it goes outside the table a little bit, that's okay. And lastly, I'm going to plot these points. So I have these coordinate pairs now I can work with. -2, 5 would be right here. -1, 4. 0, 3. 1, 2. And 2, 1. Now, since this is a line, if you want, feel free to go ahead and graph that line. Obviously, maybe not make those points so we can distinguish where those points are. But that's how we graph lines, right? And we'll get into graphing linears later this year, in just a couple weeks, actually. But yeah, there you go. Got it graphed. All right, if you have any questions on that one, let me know. Feel free to ask a question, because I would like you to try this one on your own. So why don't you do this last one? Use the equation y equals 2x minus 1. Fill in all the information we have here. Go ahead and pause the video, and then I will let you do that, and then we'll check it together. All right, so go ahead and give it a pause and give it a shot. All right, let's go ahead and check how we did here. So the important thing to know is we might use different inputs. We might use different x values. I'm going to use the same ones that I did up above. So I'm going to use -2, -1, 0, 1, and 2. And with that, I'm going to create my table. Oh no, that just took me all the way back to the top, didn't it? No, yeah. All right, let's scroll back down here. So -2, -1, 0. Excellent. And then fill this in. Okay, so this is going to be my y values now. 2 times -2 is -4 minus 1, so that'd be -5. 2 times -1 is -2 minus 1, that's -3. 2 times 0 is 0 minus 1 is -1. 2 times 1 is 2 minus 1 is 1. 2 times 2 is 4 minus 1 is 3. All right, so I have these values here. My inputs for my mapping diagram are -2, -1, 0, 1, and 2. Those are my inputs. Let's put those in a box. My outputs are actually already in least to greatest order. That's nice. So I'll have -5, -3, -1, 1, and 3. And what's cool here is that these are just going to go straight across since they both went from least to greatest. So -2 goes to -5, -1 to -3, 0 to -1, 1 to 1, and 2 to 3. Fantastic. So my coordinate pairs, use that bracket. So I'll have -2, -5. I'll have -1, -3. I'll have 0, -1. I'll have 1, 1, and 2, 3. Excellent. And now let's plot these points. So I have -2, -5. That'd take me down here. -1, -3. There we go. 0, -1, 1, 1, and 2, 3. There are all those points. And if you want, you can go ahead and create a line to connect those dots. That would be fine by me. There we go. All right, and we have graphed y equals 2x minus 1 and shown it in all these different forms. And that's actually going to be where we stop today. We didn't really get into what is and is not a function, but that's what's going to come tomorrow. Now that we know how to utilize and represent this data in all these different ways, we'll be able to easily determine what is and is not a function. So for now, this is Mr. Carter signing off. I'll see you next time.